yesterday, and I'm like, what exactly do I have to write for all these problems? And the thing is, you don't always know everything to write, but you are able to write some, and then by me going over some, I could help you. Could just jot down whatever you need. Again, homework is just, you just tried it. You gave it an honest attempt. If you need to make any corrections, just correct it. It's not a big deal. So, was there any of the problems that I could or need to help you with? Yeah.
11.
Number 11. Number 11, use the intersection to solve this. Okay, so on this particular problem, we could use the graphing calculator, or we could use Desmos. I like to use Desmos because I feel it's a little more helpful. So what I would do on this problem is, rather than try and just type it, if I type it in just as is, I wind up just getting like vertical lines. And the vertical lines aren't always clear exactly what they are. They might fall somewhere between 2 and 3 or something like that. But what I would do on this problem is I would have each side be its own graph. Bless you. So problem number 11, we're looking at it. So graphing calculator, that showed up, yes? Good. All right, so I'm going to have the left side is y equals x squared minus 3x. And then my other equation I'll have as y equals negative, go down to my keyboard, absolute value of x minus 2 plus 3. Okay, let's make it a little darker. All right, so what I'm concerned about is I want the x component of where this graph crosses. So it crosses here and here. I'm not worried about the point. I'm worried about the x value of the point. Okay? And the reason why you only want the x value is when you look at the original equation, it was x's only in the problem. So if I click here, I click here, I get an answer of negative 0.236, and I get another answer of 3.449. Okay? Does that make sense? Cool. And the reason I don't want you just to graph that whole thing, though it will graph vertical lines, it would graph vertical lines going through negative 0.236, and it's not going to tell you exactly where it's at. So just be cautious on that. Also, a reminder, my friends, if you happen to miss, I will record each lesson, so it would be in your best interest is to stay caught up, to watch the video if you get the opportunity. I mean, I know a lot of times if you're not feeling well at home, you have the strength to watch TV, you might have the strength to watch a video. Okay? Was there any other questions I could help you with? Yeah?
When it says write the equation, do you want it in like standard form or
Whatever form you feel good. Standard, point slope, slope intercept, any of them are fine. And totally acceptable and totally correct. Any other questions off the homework from last time? Another question had come to me when I was helping a student, that sometimes it says what window to use. So we have that in place because if you were using the graphing calculator, which looks like this, you would have to go in and you'd have to change the window to what they have. Okay? This is only if you're using the graphing calculator. If you're using Desmos, the nice thing about it, it zooms in, zooms out, and moves around. So there's all kinds of things you can do with Desmos that you can't do quickly with a graphing calculator. So if anytime we have a problem that says here's the window, that's basically for if you are using a graphing calculator of some sort. Okay. I wanted to choose, there's a problem. I'm going to take a look at problem number 2, just as an example. So we have y equals 3x raised to the third plus 19x squared plus 4x minus 12. Okay. So you want to try and get the graph in a way that you can see what the graph is doing. Okay, so there's a point up here. You have a point down here. You have these 3 locations here. Okay, so there's an awful lot that this graph tells us. We have solutions at -6, at -1, and at 0.667. Now 0.667 is 2/3. It doesn't bother me if you can convert a decimal to a fraction or a fraction to a decimal. If you give me the fraction answer or the decimal answer, you're totally right. So those are solutions. Solutions just means where does it cross the x-axis. But this up here is called a local max. So you might have a question at some point that might say, where does a local max exist? And you use the x value to say where it exists. You don't necessarily need to have the y component to it. Now, if they say, hey, what is the max, or what is the local max, then you look at the y component. So the terminology is kind of fishy on that both ways. But I would say I have a local max at -4.114. I have a local min at -0.08 because you're using the x portion to talk about what the graph is doing. Because a lot of times, and especially if you decide at some point that you're going to go actually take calculus, the x component talks about what the graph's doing. So a lot of times it will give you saying, hey, you have a max at 3, you have a local max at 3, you have a local min at 7. So that just means that you know you have a turning point. It's going from a high point to a low point, or a low point to a high point. So those are all things. Solutions, again, are where it crosses the x-axis. So what exactly should you write once you graph something? Well, this one doesn't have any asymptotes. Okay, so we don't have to worry about that. We'll look at the max mins. Talked about that. The intercepts means where it's crossing the x-axis. And, it just becomes things that you list. What are you seeing? Putting things like the graph curves. Okay, yeah, you might be observing that, but what else can you tell me about that? It's not necessarily incorrect. You're just not telling me enough about the graph. So we're good on the rest of the graphing. We feel comfortable with those? All right. Let's see. I was just trying to see. So tonight's assignment is very similar to last night's. One question that came, and let me just go back to here. So problem number 12, you have this, and you have a slope of -2. So there's 2 different ways you can go about this problem. You can go back to your days of Algebra 1 and realize you have this as point slope. And then you plug your values in. So this is x1, y1. Remember, when we plug in, it becomes opposite. So that becomes y plus 1 equals slope, and then opposite of +2, which is -2. So this is the point slope equation. This is where in Algebra 1, a lot of students want to go further. They don't want to leave it as point slope because it doesn't seem done. They want y equals it to be done. So if you truly wanted to do this way, and then subtract 1. So this equation here is the same as this. It's just in a different form. Okay? The nice thing about Desmos versus the graphing calculator is Desmos graphs in whatever form you're in. Graphing calculator, you have to get y by itself. Does that make sense? So Desmos is so cool that it allows you whatever form. I think that's such an advantage over what Texas Instruments offers with the graphing calculator. But what if you don't? What if you don't remember that equation and you know you have this and you have this, and I wanted to figure this out on Desmos, and I know that on Desmos if I had 2 points, I could handle it, but I only have 1 point in a slope. How could I go further with this? Any ideas? How could I make this into 2 points? Yeah. Yeah, so this you're going to use the slope. There's things you have to realize about slope is that's over 1. So if you think about this, the point 2, -1 is here. Agree? So if I was going to use this, I'm going to go down 2, right 1. So if this point here is 2 comma -1, if I go down 2 from that, my y value is going to become -3. If I go right 1 from the 2, I get to 3. So now here's my 2 points, and then if I go to Desmos, so I don't have to refer back and forth. No, I don't want that. I want Desmos. If I went to that, if I hit the plus button, it says table, and in the table I'm going to put my point 2 comma -1, and then I'm going to put 3 comma -3. Oops, 3 -3. So that gives me my 2 points, which I can't really see too well. So that gives those 2 points. That looks similar to what we had drawn on stirrup sketch. But then if you go to the next line below, if you go y1 and it's automatically subscripted, use the tilde key, mx1, and then plus b. That'll be the line that goes right through it. And notice it gives me y equals -2x plus 3, which should be the same as I had done. Go away. I had to go back a slide. So y equals -2x plus 3. So it gives us that as well. So again, it doesn't matter what form you want to graph things in. It just matters, or it doesn't matter that you leave your answer in point slope or slope intercept or even standard form. None of those really matter as far as this class goes, and I'm not going to hold you to you have to stay with a certain form, but there's just certain tools that you can do that will help you along, and Desmos will help you. And that the powerful tool in Desmos, I mean, it's great that your calculator, you can plug points in, it'll give you an equation back out. Well, it gives you the slope and the y-intercept. You have to realize plug those back in. But the big thing is knowing if I call this value y1, it has to be here. The tilde means that's the command that says to Desmos, we want to make the equation off this. We know we have y equals mx plus b, so the m will put in there x of 1 because our x value is called x of 1, and then plus b. And again, you just plug your m and your b into it. It'll give you your line of best fit, or your linear equation that goes with it, or whatever equation you have. Okay? So, time we out of here? 47. Okay. So I want to play with this table a little bit more. Okay, so let's say that we are collecting data on the braking distance of a vehicle. So if a vehicle stopped, what's the braking distance? It's 0. Let's say the vehicle is doing 5 miles per hour and has a braking distance of 16. And then let's say the vehicle's doing 10 miles an hour and we have a braking distance of, let's go 36. Okay, so this seems that it's forming a straight line. If I go continue on my thing, let's just keep counting by fives. Let's say if we're doing 15 miles per hour, the braking distance is now 64. Okay, and again, I can get this. So this is starting to show a little bit of a curve. So if I did this, if I went, this should form a parabola. Okay, so if I go y1 tilde, okay, standard form of a parabola is, let me see if I can do this right. A x minus h quantity squared plus k. Oh, it's not going to do it. All right. Oh, that's what the problem is. X sub 1. There we go. Okay. So this is the standard form of a parabola. You have to know, and if we ever have an equation like this, I will make sure I put the standard form of a parabola. But this gives us an R value of 0.9996, R squared value. That means it's really good. The closer this is to 1, really good. If you got a 99.96% on a final exam, you're not asking your teacher, hey, what 0.04% did I not know? Okay, you're like, dude, I'll take that. I'm done. But if I were to plug in my equation, I would be able to find that I have a parabola of y equals 0.12 quantity x plus 10.1667 close parentheses squared minus 12.203. But the nice thing is it draws in the parabola. And when you look at this, it's like, well, it becomes quite obvious that these points fit really nicely on this parabola. Okay, these values here in the x direction don't make sense. Okay, because I don't have a negative minus the r I was doing. But that's actually, another key feature that this will deal with. So it's kind of understanding, do you know where this exists? And this is, and I can tell you on tonight's assignment, we don't have any quadratics that are finding the equation of it, but I just want to show you that this is available for you to play with. So the assignment for tonight is graphing review number 2. And what do you say we do the odds? Sound like a deal? If any of you need to go get your book, you're more than welcome to go and over to Bare Necessities and grab your book. But I assigned odds on the 12th. I'll check that off tomorrow. And remember, if you owe me an old assignment, you're welcome to do it. Just show me, and I'm happy to update it in the grade book. Sound good? Sound good?